Hi, I am Muhammad Amir Hakimi bin Mahmud with geometric B0920100081. So today I'm going to present about the introduction. So torsion is a twisting of an object as a result of an applied torque. So the amount of twisting depends on 1. Applied torque, 2. Length of object, 3. Modulus of rigidity, 4. Torsional constant. So there is a picture of a torsion, how is torsion work, and there is also there is a formula for the torsion.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Huda Binti Sarman. I'm gonna talk about the objective. First, to determine the torsion loading from cordless drill. Second, to draw the detail of FBD from the actual structure and relate to the problem. And third, to develop equilibrium equation from the FBD drawn. And fourth, to find the maximum torsion force that will fail the cordless drill. Fifth, to determine the allowable force from the factor of safety FOS used in the cordless drill. Next, I'm gonna talk about the actual structure. From the picture, you can see it is the actual structure of the cordless drill. The material of the structure is used molybdenum high-speed steel. It usually used to manufacture a variety of tools such as drill bit, taps, and reamers. For the dimension, it has 200 mm for the length, 50 mm for the width, and 190 mm for the height. The weight of the actual structure is about 1 kg. For the material modulus, it has yield strength is about 1000 megapascal, compressive yield strength is about 3250 megapascal, Young's modulus of elasticity is about 200 gigapascal. Lastly, for the ultimate tensile strength is about 1200 megapascal.
Everyone, it's me Monishavani Sivakumar and geometry B0920100345. Okay, now I'm going to explain about free body diagram, which is FBD and calculation of cordless drill. First of all, here the FBD of cordless drill. From the FBD shown, we just know the value of length and diameter drill bit only. The measurement value for the cordless drill, length is 85 mm. And the diameter is 5 mm and the radius become 2.5 mm. For the assumption value, force is 110 Newton and also the factor of safety is 1.85. Okay, for the calculation part, we calculate with firstly applied torque, second angle of twist, third maximum shear stress, fourth force allowed, and the last is factor of safety. The applied torque, we use formula of force times with radius, which is 110 Newton times with 2.5 mm, and the value of applied torque is 0.275 Nm. And for the angle of twist, we use formula of pi divided by 2 times with radius power of 4, which is pi divided by 2 times with 2.5 mm power of 4, and the final value is 6.136 times with 10 power of negative 11 meter power of 4. For the angle of radian, we use formula torque times with length and divide by portion area times with modulus of rigidity, which is 0.275 Newton meter times with 85 mm, and with 75 giga times with 6.136 times 10 negative 11, and the value of the angle is 0.0005 radians. Okay, for the maximum shear stress, we use formula torque times with radius divided by angle of twist, which is 0.275 Newton meter times with 0.25 mm divided by 6.136 times with negative 11 meter power of 4, and the value is 11.204 times with 6. Okay, lastly, for the allow force, we use torque times with area. When the area is not given in question, we use normal formula pi times with area. Okay, for the formula, 0.275 Newton meter times with pi 2.5 millimeter power of 2, and the value of force below is 5.39996 times with micronewton.
Hi, I'm Muhammad Ahmad Fahmi bin Armi. My number metric is B0920102442, and I would like to tell you about the analysis and discussion. As we know, torsion is twisting an object caused by a moment acting or subjected to the torsional load. When the ratio of a material ultimate strength to the actual stress or the maximum permitted stress when in use is called the factor of safety. The product of torque and length is directly proportional to the angle of twist. Meanwhile, because the result is greater than 1, the safety factor for this project showed that materials were safe in this working environment.
Hi, this is Amirul. So for the conclusion, these cordless drills are safe because the factor of safety are greater than 1. We also discovered how firm this cordless drill is. We also able to determine the maximum shear stress, angle of twist and torque value from the equation of equilibrium. We also able to determine the limitation of the drill machine that can cause errors, and we are also able to finding out about the Hooke's law where the maximum strength of the drill bit appears to break can be calculated. And lastly, the free body diagram that label indicate how the cordless drill apply the moment and the force to the plank. That's all. Thank you for watching.